Alright, let's do this. You guys ready?
No.
Too bad, so we're going to review our notes, but before that, I'm going to introduce the new student. Say hi.
Hello, my name is.
Yeah, go take a seat. Okay, who wants to tell us what we did first yesterday?
I actually don't know what's going on,
Alright, get up here, I'll show you.
but I'm already standing.
So, let's start with Lewis dot structure. Lewis structure is a two-dimensional model that represents covalent bonds as straight lines and unbonded. Valence electrons, those in the outermost energy level of an atom. As dots, atoms are most stable when their outermost electron shells are filled.
I don't think a definition will help me understand this.
Alright, then let's enter covalent bonds. They are more complicated and works if you follow the steps.
What are you doing?
What are you doing? No, not paying attention. That's what. First, figure out how many total valence electrons are available. Each hydrogen atom has one valence electron, and oxygen has six, for a total of.
8.
Hydrogen and oxygen don't have enough electrons to be stable, so they share electrons to make up for it, which creates a bond between the atoms. Then lay out the molecules and create the bonds. Oxygen is in the middle, being bound to both hydrogen. In this model, each bond requires a pair of electrons, so we use 4 of the 8 available electrons to form a bond. Now fill in the outermost energy level. Hydrogen only needs 2, so they're full. Oxygen needs 8 electrons, so take the remaining and surround the atom to complete the structure. Don't forget to use lines as a representation for the bonds.
Simple enough.
Well, it gets trickier. Here, let me show you carbon dioxide. Carbon has 4 valence electrons, and each oxygen has 6, for a total of 16. We put carbon in the center, and now we have to fill in each of the atom's outer layers with 8 electrons. But we're short of electrons to have them just share one bond with each other, so we have to kick it up to a double bond, where there are 2 shared bonds between the atoms, creating the full 8 that we all needed. This is an example of the variety of different structures there are, all of them different from each other as much as animals do.
But it can be more simple than that. Like, what if you use 2 of the same atoms?
Like nitrogen, just 2 atoms bond together, right?
No, nitrogen has 5 valence electrons, and there are only 2 of them, so 10. When you set up the structure and try to use a single bond, you are missing 4 electrons to complete both. And a double bond won't work, 2 more will still be gone. But if you use a triple bond, it would fill both atoms with the 8 electrons they needed.
But 3 is maximum level number of bonds that can be formed. So, do you understand now?
No.